If the sun were to explode, it would mark the end of life in our solar system, ushering in an unimaginable catastrophe. The sun is the center of everything we know, providing light, heat, and energy, and holding our entire solar system together through its gravitational pull. Without it, the Earth would be nothing but a drifting rock in the void of space. However, let's get one thing clear: our sun cannot naturally explode as a supernova. That fate is reserved for stars at least 10 times the size of our sun. Instead, our star will die in a much more measured, though still dramatic, process, expanding into a red giant before shrinking to become a white dwarf. But for this hypothetical scenario, let's imagine that the laws of nature no longer apply, and our sun defies its inevitable end. What if it exploded right now? Let's explore the mind-bending consequences. Immediate effects: the 8-minute countdown. The first thing you need to know is this: we wouldn't even know the sun had exploded until 8 minutes and 20 seconds later. Why? Because it takes light and all electromagnetic radiation 8 minutes to travel the 150 million kilometers, 93 million miles, from the sun to Earth. So, if the sun exploded, the light from the explosion would reach us, but not immediately. By the time we saw the flash of light, it would already be too late. And because sound can't travel through the vacuum of space, we wouldn't hear anything. The sun would explode with no sound, just a blinding flash of light racing toward us. Deadly impact: neutrinos, gamma rays, and X-rays. The first wave of death would come from neutrinos. These nearly massless particles travel at nearly the speed of light, carrying around 99% of a supernova's energy. These particles would pass right through Earth in mere seconds, causing organisms to boil from the inside out in an instant. But that's just the beginning. Next, the electromagnetic radiation from the explosion, primarily gamma rays and X-rays, would reach Earth in the same 8-minute window. These incredibly high-energy rays would annihilate all life on Earth, killing every living thing almost immediately. The side of Earth facing the sun would be instantly vaporized, and the shock wave of the explosion would obliterate the planet. No one would survive. Long-term effects: an unrecognizable Earth. If, by some miracle, Earth somehow managed to survive the initial blast, and that's a big if, the long-term effects would be equally catastrophic. Impact on Earth's climate. Without the sun, Earth would be left to cope with the aftermath of the explosion. The sheer amount of energy released would cause an unprecedented climate shift. The radiation and particles would lead to a dramatic rise in temperature, creating a greenhouse effect so extreme that it would cause Earth's oceans to evaporate. As the oceans vanished into the atmosphere, a thick layer of clouds would form, trapping heat and preventing it from escaping into space. This would create a world that is far too hot for life to survive, a lifeless, scorching wasteland. Even more terrifying, the sun's gravitational pull holds Earth in its orbit, along with all the planets in the solar system. Without this anchor, Earth and the other planets would begin drifting aimlessly through space. The delicate balance that keeps our planet in place would vanish, and we'd be cast adrift into the void, no longer bound to the sun's gravitational center. Impact on the solar system. The sun's explosion would have far-reaching effects on the rest of the solar system. The massive energy released would send shockwaves through space, altering the orbits of the planets and other objects. Planets would be pushed out of their current paths, and the entire solar system would be thrown into chaos. The asteroid belt, located between Mars and Jupiter, would be completely destroyed. The asteroids would either be vaporized by the explosion or flung into the deep reaches of space, lost forever. The outer planets like Jupiter and Saturn would experience some of the most dramatic consequences. These massive gas giants rely on their internal heat to maintain their structure and atmosphere. Without the sun, these planets would lose much of their internal heat, causing them to become cold, dark, and inhospitable. Moons that were once hospitable to potential life would freeze, their environments turning into frozen wastelands. Would humanity survive? As we've touched on earlier, If the sun were to explode suddenly and without warning, the simple and stark answer would be, no, humanity would not survive. In this catastrophic scenario, nothing would escape the explosion except possibly some resilient bacterial life. If, however, we were somehow able to anticipate the sun's explosion, there might be a tiny window of time for humanity to prepare for the inevitable. But even with advance warning, survival would be no small feat. The earth would freeze, turning into a barren, lifeless wasteland without the sun's warmth. To survive, humanity would need to think creatively and find a way to shield itself from the ensuing destruction. One possible solution would be to retreat deep into Earth's underground. As we descend into the Earth's depths, temperatures actually rise, a phenomenon that could potentially buy us some time. With enough resources and the right technologies, underground fortified bunkers might give humanity a fighting chance to survive for a few years, perhaps even decades. That's assuming the planet itself doesn't get completely destroyed. As we concluded earlier, it most likely would. While it's hard to predict the exact fate of every planet, Earth, along with Mercury and Venus, would almost certainly be obliterated by the sun's catastrophic explosion. Effects on the Oort cloud and beyond. Even the distant reaches of our solar system would not escape the sun's violent end. The explosion would create a massive shock wave that would travel out to the Oort cloud, a vast, icy region surrounding our solar system, extending from about 2,000 to 100,000 astronomical units from the sun. To put that in perspective, 1 astronomical unit, is the distance from Earth to the sun. This explosion would disrupt the orbits of trillions of comets and icy bodies. Send many of these objects hurtling toward the inner solar system, where they might collide with planets or even with one another. Push others out into interstellar space, scattering them far from their original home. Trigger a dazzling but deadly comet shower, visible from neighboring star systems, creating a cosmic spectacle that would undoubtedly be noticed by any nearby civilizations. The shock wave would continue to spread through interstellar space, gradually losing power but still detectable by any advanced alien civilization with the right technology to pick it up. Theoretical artificial triggers. While the sun's explosion as a supernova is beyond the realm of possibility, there are theoretical concepts in physics that have explored the potential of triggering catastrophic solar events artificially. One such theory is the Hubble criterion, which suggests that by creating higher temperatures and densities in a specific region of the sun's interior, it might be possible to trigger a self-sustaining thermonuclear reaction, potentially leading to an artificial solar explosion. However, this type of event would require technology far beyond our current understanding and capabilities. Any civilization possessing such advanced technology would likely understand the catastrophic consequences of triggering such an event and would avoid it at all costs. Moreover, the energy required to artificially induce a solar explosion would be so vast that it would likely be far more efficient to find ways to harness the sun's energy through other means. For now, this remains purely theoretical, firmly situated in the realm of science fiction rather than science fact. Conclusion. The hypothetical explosion of our sun would be one of the most devastating events imaginable. Within minutes, all life on Earth would be extinguished. The inner planets Mercury, Venus, and Earth would be completely obliterated, while the outer planets might survive, but be forever altered. This apocalyptic scenario is, fortunately, purely speculative. Our sun does not possess the necessary mass to end its life as a supernova. Instead, it will go through a much slower and more peaceful process over the course of billions of years. However, the study of stellar explosions and the death of stars helps us understand our cosmic origins. The elements that make up every part of our bodies, carbon, nitrogen, oxygen, and everything heavier than iron, were formed in the hearts of ancient stars that lived and died long before our sun even existed. Our existence, in that sense, is a cosmic anomaly, a moment in time when stardust has come together to form beings capable of contemplating the very stars that gave us life. Though the explosion of the sun would mark the tragic end of Earth's story, the elements of life will continue their journey through the cosmos, perhaps one day creating new worlds and new possibilities for life elsewhere in the universe.